Hi guys, welcome. Today I want us to look at a possible interview question as a developer, and the question is, we are to check if a singly lane list has a cycle in it. Okay, so before we can go ahead with this problem, let's look at this algorithm by Floyd. So, what is Floyd cycle detection algorithm? So let's try to understand this before we go into the main problem. So the Floyd cycle detection algorithm, also known as tortoise and hare algorithm, is a widely used technique for detecting cycles or loops in a linked list or any other data structure that can be traversed sequentially. The algorithm was developed by Robert W. Floyd in 1967 and is used to find circles in sequence of elements efficiently with constant space complexity and linear time complexity. So let's let's try to understand how the algorithm works. So the algorithm says that first we should initialize two pointers, often referred to as the tortoise and the hare, at the beginning of the sequence, that is head of the linked list. These pointers initially both point to these pointers initially both point to first element in the sequence. And so it says that we should have two pointers, and at the initial stage both will be pointing to the very first element in the sequence, or the very first element in the list, right? So point number two says move the tortoise one step at a time and the hare two steps at a time. Okay, so what it means is that, so this means that in each iteration the tortoise advances by one element and the hare advances by two elements. Okay, so it means that one pointer should move two times two of the other, right? So here in this case, tortoise will move slowly, and then the hare will move faster than the tortoise. Okay, so point number three: continue moving the pointer in this way until one of two things happen. Okay, one of two things happens. Number one, the pointer meets at the same element. They point to the same memory location. This indicates the presence of a cycle in the sequence. Okay, so since one is moving faster or one is moving ahead of the other, if there is a cycle, they will eventually meet at one location. Okay, so the hare reaches the end of the sequence, that is, it encounters a null or sentinel value. In this case, there is no cycle in the sequence, and so since the hare is moving faster, if there is no cycle, it will get to the end of the list or the end of the sequence without meeting the tortoise or without meeting the other pointer. Okay, I hope it makes sense. So let's whiteboard it and see what it actually means. Okay, so if you have a sequence of elements, okay, linked together, okay, so eventually let's say no. Okay, it says that we should have two pointers initially pointing at the first element. So let's say this is our, say, hair, and then this is the tortoise. Okay, initially, and then you move this two steps ahead, okay, of the tortoise. So the tortoise will move one after the other. One, let me name it one note, first note, second note, third note, fourth, and then the fifth note. Yeah. Okay. So if the hairs gets to the end without meeting the tortoise, or gets to the gnaw or the terminating bite or whatever it is, and without meeting the T, means that there's no cycle. Okay. So how do we know if there's a cycle? Now let's look at this. So here the T is the slow pointer and the H is the fast pointer. Okay. So they initially start at the beginning of the node of the list or of the sequence, and then the T moves one node at a time, whilst the H moves two nodes at a time. Okay, so the advances two, so H is at 8, 10, 12, and then 5, 7, 9. Okay, so it means that the H moves two nodes ahead of the T. Let's observe the T as well. So T moves one at a time, one node at a time. Okay, a node at a time. Okay, now since H is moving faster, it means that they will eventually meet if there is a cycle, right? So this is the cycle. Then T7, now 7, 8, then they will eventually meet at 9. So this is what the algorithm is trying to explain, that you should first have two nodes, each pointing at the very first element, and then one advances ahead of the other. So H move faster. So H move two in a multiples of two in this case, right? So 2, 4, 6, 8, 10, 12, and so on. Whilst the T moves a node at a time. So 2, 3, 4, 5. So 4, 5 moves to 6, moves to 7, whilst the H is moving faster, and then they eventually meet at 9. Okay, so let's look at the code. Now, when you look at the code, the algorithm says that we should have two pointers. Okay, so we have our slow PTR, and then we have our fast PTR. Here we check if they are not null. Of course, if they are not null, we can't. If they are null, we can't proceed. So if they are null, then we return 0 and exit. But if they are not null, we point the slow PTR to the very first element, and then you point the fast PTR. It means that at initial stages, or at the initial stage, we point it to the very first element, and then when we advance ahead, or the second iteration, we move slow PTR to the next, and then fast PTR times 2 ahead of the slow PTR. So that's why I have next, next. Okay, so this is moving 2 times ahead of the slow PTR. Now here we have this statement to check if slow PTR is equal to fast PTR. So if the slow PTR is equals to that, it means that we should return one. It means there's a cycle. Okay, if this point to that, it means there's a cycle. So if there is, then we return one. Okay, and then exit. So that is what it is to check if there is a cycle in a singly linked list. Thanks for watching.